Throughout history, humans have been on a quest to decipher the meaning behind our dreams. Dreams have the ability to bend time and space and create virtual worlds that border on the bizarre. But why do we dream? No one really knows. Now, science is digging deeper, giving us new tools to peer into the innermost recesses of unconscious thought. To understand what controls the dreaming brain, researchers analyze data from tests like EEG, PET scans, and functional MRIs. Brainwave activity from EEG tests shows a dramatic contrast between our waking and sleeping brains. When we're awake, our brains operate with faster alpha and beta waves. When we sleep, two slower patterns called theta and delta waves take over. PET scans, which observe blood flow in the brain, also show a stark difference between a brain that's awake and a brain in deep sleep. In the awake brain, you can see the areas that are most active in red and yellow. In the deep sleeping brain, activity dies down dramatically, with purple areas showing the least activity. Most of us think of sleep as a constant passive state, but we're actually moving through a series of cycles controlled by neurotransmitters that act on different parts of the brain to induce sleep and waking up. During a typical night, most people experience 4 to 6 cycles, each lasting 90 to 110 minutes. About 2 hours a night is devoted to dreaming. The first 2 stages of each cycle are the lightest phases of sleep. Here, dreaming rarely occurs. Then, we fall into a deeper sleep. Heart rate, blood pressure, and body temperature all fall. Try waking someone up during the deep sleep stage of their cycle, and they're at their groggiest. During deep sleep, we have vague, illogical dream fragments that we forget almost instantly as soon as we wake up. It's during the last stage of our sleep cycle, the rapid eye movement stage known as REM, that most vivid dreaming occurs. Surprisingly, REM sleep shows a similar pattern of brainwaves to those of our awake brains. REM sleep starts when an area at the base of the brain called the pons is activated. Think of it as a computer control center capable of switching on and off certain functions. During REM sleep, the part of our brains where memory and emotions are centered is switched on and highly active. But the area that controls logic and critical thinking has hit the snooze button and shuts down. Motor neurons in our spinal cord are offline, causing temporary paralysis. This prevents us from acting out our dreams, yet we still experience emotions such as fear and anxiety. Although no one knows exactly why we dream, there are new theories. One popular neurobiological theory is the activation synthesis hypothesis. Dreams don't mean anything at all. They're merely electrical brain impulses that mix up random thoughts and images from our memories during REM sleep. The frontal cortex then creates a story out of this jumbled up brain activity because that's typically what it's meant to do. Evolutionary psychologists have another idea. The threat simulation theory suggests that dreaming is an ancient biological defense mechanism. It's designed to simulate potentially threatening events to give us an evolutionary advantage by developing the means to perceive and avoid them. Here's what we do know. During REM sleep, our brain forms neural connections to strengthen memory and recharge our supply of neurotransmitters. It's a necessary and vital function, and all the more reason to get a good night's sleep. Pleasant dreams.